think it would be best to chia talk next rather than. Okay, so. Okay, make it up.
Okay, next we're going to have a student presentation for proposal. We had from 5 students down to 2 students wanting to propose, but the end result is that 2 of our students are proposing together. So you'll hear a proposal from them, and then concluding remarks, which Rebecca will do. This is Tia Kui, who's a graduate student at Johns Hopkins.
Hi, this is a joint proposal proposed by me and David Guthrie. The topic is soft semantic tagging and class-based features for maximum entropy training. In the next few minutes, I will talk about what is soft semantic tagging and why we need soft semantic tagging. And David will talk about class-based features and topic features. And finally, it's our proposals. It's well known that the philosophy of ME training is to maximize the entropy and at the same time satisfy all the given constraints. This is a general formula of a given constraint. Okay, sorry. So we want, for the given feature Ki, we want the theoretical expectation of this feature equal to the empirical expectation. We call them targets. Usually, people are more interested in finding a conditional distribution P of y given x, and at the same time assume that the P head of x, which we found from the training corpus, is equal to the real P head P of x. And on the other hand, the targets of the feature can be simply calculated from the training corpus. In many cases, we will have only a small human annotated at training corpus, and we have a huge amount of unlabeled corpus. If we get our feature set only from this small training corpus, then it's very possible that the target of the features would be not reliable. It might be far away from the truth. In this case, we won't get very good models. So the first problem is how we can use the huge amount of unlabeled corpus and get some useful evidence from this corpus to improve the empirical targets of our features. Moreover, there are a bunch of useful informations come from the dictionary and WordNet. Those knowledges may not be expressed in the small amount of training corpus, but they are very helpful and they are indicative in this semantic tagging task. So the second problem is how we can use this information effectively to help our semantic tagging. Let's look at a small example. Suppose we see the keyword club 4 times in the training corpus, and it can belong to different semantic categories. We can get some probability distribution from this training corpus, and we can use this information to tag these instances appear in the unlabeled corpus. When we are doing this soft tagging, we name it soft tagging because we are not going to give 1 or 0 to this observance, but we give some fraction of credit to each possible semantic category. And during this process, actually we can use more information outside the knowledges. For example, suppose we see the word golf just in front of a club when it appears. Then we are pretty sure that a club will not belong to category Y1 and category Y4. And then we will redistribute the whole probability mass among only these 2 possible semantic categories, Y2 and Y3. After we finish this part, we can combine those 2 corpus together and we can recalculate the expectation, the target of our features. So the features of, here I didn't, X is club. So the features of K of club and Y2 would be equal to 1, which comes from the training corpus here, and plus 1 over 3, which comes from here, divided by the total number of instances. So generally say, we will have two couples. One is human annotated, and one is the huge bunch of unlabeled data. And at some time t, we will have a model, and we can use this model to soft tag these unlabeled couples. And then we can collect the evidence from those couples, recalculate the expectation, and retrain this model. We are hoping that this kind of new target would be closer to the truth, and therefore we can get a better model from here. There are a lot of advantages from soft tagging. Just as I have said, first we can collect more evidence from this huge bunch of unlabeled couples, and we use this evidence to help improve the targets of current feature set. Also, because we are collecting more evidence, and during this process, some features might get less reliable, so we can remove it from the feature set. On the other side, some patterns can be seen more and more frequent and meaningful, so we can add it to the feature set. This is the framework we built in our workshop. And here is the Sheffield human annotated training corpus, and this is the huge BNC and unlabeled corpus. And we can initialize this. We can initialize this corpus with some knowledge from this training corpus, and then we get feature set from both corpus, and we use ME model to train, and we get model. When we get this model, we can use it to retag those unlabeled corpus. If you do this process mathematically, you will find very interesting thing, that is, if we use the model exactly like it is to soft tag these unlabeled corpus, you will find that after the whole thing converge, we actually get no benefit from this unlabeled corpus at all. But when we are doing this process, we suppose that we have a very knowledgeable person, and he knows a lot of things outside of the training corpus, such as the dictionary, the word net. And during this retagging, he can actually put his knowledge onto it and reshape this whole process. This is our knowledge person. And he has some knowledges from the dictionary, word net, or word clusters outside. And when he does this soft tagging, he puts this knowledge into it.
Just when you say that you get no benefit by going through this feedback loop, does this mean you've done it and you haven't found any benefit? Or is this supposed to be just obvious that there's no benefit?
Well, actually, this is not an obvious thing. At first, I want to formulate the whole process as with EM algorithm, but later I found if we didn't change the feature set and we just use the model exactly when you write these formula things and you do these mathematical things, you will find that all the knowledges will only come from the training corpus. So this unlabeled thing, it will convert to the same model. That's very interesting. So and for this part, my opinion here is that we have a lot of knowledges. Some knowledge can be expressed in the training corpus, but some knowledge is not so easy to be expressed. Like Robert just showed, he can get a lot of conditional knowledges from the word net. And then we have two ways to use this knowledge. One way is to put it as the normal ME constraints, and another way is to do it like this, to force some knowledge in, but we are not put this knowledge as some hard constraints. Here is a preliminary result, and Fred just showed it to you. And it's I don't know that the result, the error rate goes up. I think the main reason is because we are doing this big iteration on some corpus, but test it on another corpus, on the holdout data. That's one reason. And from this whole framework, we have a lot of other things to do. For example, when we are doing this iteration, we are using dictionary information to redistribute the probability mass. And when we do that, if we will put 0 to that semantic category slot if this is not possible given by the dictionary. Actually, this is a very radical step. Maybe we can take small steps when we are using this knowledge. And also, during this process, I fixed the feature set. That means I didn't add new feature, didn't remove old feature. I think that's another reason that this curve goes up. We will try in the future that to add some more useful features to change the feature set. And third, in the whole process, we always change the unlabeled corpus. That is, we always subtag the whole unlabeled corpus. But actually, we can, at some time, we can be pretty sure that some word should be tagged with some semantic category. In this case, we can actually move this instance from this unlabeled corpus to the training corpus and fix the label there. By doing this, we are pretty sure that the things will be verified. And finally, and most important of all, as everybody knows, feature selection is a very important thing during this whole process. It's well known that sparse data leads to unreliable or too few exchanges. And I did experiment which showed that always choose the most frequent patterns as features are not always result in good models. And the experiments presented by David also showed that use entropy and neutral information to guide this feature selection is very promising. And now David will present it in detail. Thanks.
Thank you, Jim. This is David Guthrie from University of Sheffield.
Okay, so we know that we have problems picking features for the entropy model because the contextual data is so sparse. But we've shown during this workshop we've had pretty good results if we cluster this data. And we did this with adjectives and made clusters of the adjectives based on the semantic categories using low entropy. And used those. Jerry showed that we used them for picking preferences, and I showed some results where we used them in the entropy model as features and had pretty good results. But we didn't think they were the best results, they weren't great, and we wanted to do this more generally. So we came up with a more general approach to clustering and showing it using adjectives. And so we make an arbitrary set of adjective clusters maximizing the mutual information between the classes and all the sets of adjectives. There's the formula, so the entropy of the classes minus entropy of the classes giving the adjectives. And so we just kind of had the feeling that, of course, for unknown words, the selecting our adjective classes based on the mutual information between classes and adjectives without the words would probably do better. And if we were given the words, we could probably pick better classes for the known words. So our observations was that picking optimal clusters was pretty challenging. So we began with 3 requirements that we wanted to keep for our clusters, and they were that the clusters must have sufficiently high counts, the entropies of the clusters should be small, and the mutual information between them and the classes should be high. And one way we found it worked pretty well was using these kind of heuristics for picking these classes. And we took adjectives and put them in classes if they were good predictors for one tag. We made another class for adjectives that were good predictors of 2 tags. And single classes for very frequent adjectives with moderately high entropy. So This was so they wouldn't bias the other groups. If it was an adjective that was extremely frequent, it could be in a class all by itself and wouldn't bias the other groups, and it would still be a fairly good predictor of a certain tag. And then we had a jump class for adjectives that we didn't want to put in any of the other classes because they had low frequency or low entropy, or high entropy, sorry, and the rest class for all other adjectives. Then we, making all these classes, we sorted them all by their mutual information and took the, moved the lowest scoring ones to the rest class. So this was just kind of a general experiment we did when we picked classes based on the rules from the last slide. Our entropy for all classes is 1.65, and we decreased that by 0.28 when we used our sets of adjectives that we picked, which was pretty good. And for classes given words, it starts at 0.15, and we decrease that by 0.1, sorry. And we also ran some experiments with these. They're still preliminary, using these classes in Weka, and they showing they were pretty good results. Another thing we did to improve the tagging, and would like to do more of, is using topical features for documents and for local context. So our hypothesis was that knowledge of a topic in a document can help you predict the semantic category of the nouns in the document. And we did this in two ways. One was the BNC topic as a feature. All BNC documents have a very, very coarse topic in their header, things like science or politics or business. And so we use these as features, and we also use the long and subject codes, which have been mentioned briefly earlier, but we haven't really gone into detail on those. Each noun in the Eldos dictionary is assigned a set of possible subject codes which correspond to definitions in the dictionary. Some definitions don't have them, but many do. And there are things like ring. This is just two of rings. It has a jewelry subject code and it has a communications subject code. Stock has many more than this, but it does have business, animal, food for subject codes. So we thought that using these subject codes and modeling them in the document, we could probably reflect its topic. So we modeled the distribution of these subject codes and computed a topical feature score for each subject code and for each document. And then we maximized the mutual information with the tags of a category, between the category and the topical feature. And ran these using decision trees and have also gotten pretty good results with those. So our proposal basically breaks down into two parts. One is that we want to investigate the theoretical and practical aspects of the bootstrapping process and the stock criterion. We also want to investigate the contribution of contextual and topical features and the result and their improvement on the resulting model. So as far as the first point, we want to know how to use outside knowledge, especially conditional features, properly in soft tagging. And we want to investigate the use of reliability on restructuring training data during estimation. And the second part is we'd like to investigate the ways to overcome the sparseness of contextual information and explore the use of dictionary-based subject markings. Other things I'd also like to explore, things like using WordNet contextual density to model topic, and like to determine the contribution of local contextual information versus document contextual or topical information. I think that's all. Any questions? Yes?
Just to try to get this straight, so what you're trying to basically do is you're trying to learn a bunch of meta features, so to speak, off of some corpus that you have labeled. And then you get some new corpus in you've never seen before. You can't possibly do anything with it, so in order to make a model, you're going to use these predetermined features and, sort of cross your fingers and hope for the best, right?
Well, we're going to feed these features into the, we want to pick features that are representative of the corpus so that we can feed these into a maximum entry model to learn off of these features and hopefully relearn and maybe change the features at the relearning process. And hopefully, yes, that's how we want to do it. Yeah.
I'm always cautious about the use of the word feature because I think that we're here mixing up, and you meant a different feature than what means in maximum entropy. You just meant certain parameters and whether the features should depend on some parameters and not on other parameters, while the feature is really the composite, namely, which parameters are determining the marginal distribution that we're after.
Okay.
Okay, thank you.
Okay, and Rebecca will give us. So the last little bit is our conclusions for the project.
So we had a number of experiments and things, and I will try to give an overview as we could. The problem of semantic tagging was approached in quite different ways. And we have basically 4 big classes. First of all, it's an information retrieval inspired approach, and it was quite successful. Then we can cluster the supervised method that try to incorporate contextual feature, basically using maximum entropy as the basic training technique. And then we have been suggesting and partly experimenting a way of using in a bootstrapping manner the maximum entropy duplicate. And Fred was talking about that. And there was a track of people that was not using the tag at all, very strange people that was making some unsupervised use of the corpus, basically using the corpus only for testing. We think that some achievements are first of all, a very large empirical evidence derived from the corpus that we have. Hundreds of experiments trying to look at the dictionary, syntactic information, word length, and so on. And the idea that class-based kind of parameters are better than the other parameters is an outcome and general guideline have been derived. And we have also unsupervised taggers as accomplishment. Let's try to see what is the outcome. Semantic tagging as a sort of intermediate level task between named entity tagging and word census ambiguation has been one of the first ideas. And we are showing that over BNC, this task is viable with very high accuracy. And the accuracy that most of the methods between 93 and 94 was quite good, and we hope that this kind of accuracy is also due to the fact that we try to use in the best manner as possible, given the background here available in Johns Hopkins of the statistical modeling of semantic knowledge. And so this is this field and this task can be a stimulus for better integration. That most of the project this year were trying, integrating more kind of linguistic information in statistical modeling. So given the high accuracy, can we go on holidays now? And then that's the end of the story. I mean, there are several new things that are in the immediate future and some more complex. First of all, the corpus as it is can be already used for stimulating, let's say, kind of work in machine learning for use of this information in real tasks, ranging from machine translation, information retrieval, and also the kind of question answering, pattern-based approach to question answering should be, let's say, tested on this new data. Then this project was focusing on add nouns, right? And we know that verbs are other kind of animals, right? So we need to try to exploit this data to look at regularities and clustering and semantic classification of verbal kind of information. And maybe incremental learning that looks first to nouns, then to verbs, and then come back to noun are also to be tested soon. The real kind of medium-term and long-term challenges are the fact that unseen phenomena for all of the methods still represent our cases, and the bootstrapping is suggesting a way to deal with that, but the probabilistic model are to be faced with the fact that rare phenomena are not always impossible, when the lexicon very often suggests that some phenomena are impossible. So that's something that challenged the modeling, the probabilistic modeling of this information, like David and Shia will be trying, hopefully, in the next months. And another point is that the existing lexical resources provide very powerful information, but this kind of 6 weeks work didn't demonstrate really how much these benefits can be, let's say, exploited usefully in the work. So, first of all, some conclusion is about the kind of atmosphere we found here, and we would like to thank all the John Hopkins faculty and staff, people that allow us to work in a very nice and in very good conditions. Fred was part of our team and was really making this kind of nice situation even nicer and very effective for all of us. He was very patient about it.
You mean you're doing that extra cookies?
Sorry. Okay. And my conclusion is with respect to the team that has been working with us, from the undergraduates to the senior. Most of the work that you have been listening is really the outcome of a cooperative effort, and although some of the names were just grouped under the kind of labels, most of the interaction was making possible all of these. Special thanks to some seniors, and Anish was not presenting, and Kalina were quite contributing with the infrastructural work on the data that we were manipulating, and this has been was making everything easier and possible. And I would like to thank Louise that I'm here to represent, but she was possibly the first person that had this idea about this semantic tagging, and basically this was this outcome is also proving that this is a very nice direction. And she was also involved in the definition of the data structure and the dictionary. That was really an hard and boring stuff since the beginning. And the ideas about bootstrapping and the use of adjective classes, for example, and all the work that she was nicely doing from, let's say, data preparation to software design and data analysis was for all of us very, very, very important. So I want to thank her in a special manner, and I think that this is all.
Maybe there are some questions, first questions relative to this project, and then I think we'll have a little bit of a period of discussion of the entire workshop. So if there are any questions having to do with this project, this is the time to ask them.
Just want to ask Roberto his thoughts about that. You mentioned somewhere in the last slide that the learning of the verb argument patterns. Can you say how, what prospects you see that being possible?
Yeah, you saw some of the work has been done with the long-term classes that are quite general. But the idea is that for some of the words that we have, We can easily specify these classes. For example, we know something about subject codes, so we know kind of foods or chemical materials and so on. So the idea in an application in which it is possible to find relation between things like in the plate filling, you are to follow through a document, so the availability of semantic tags is a way to reduce the sparseness of the data. So even in weekly or let's say a weekly supervised method, the availability of this semantic tagging technique can be helpful for example, looking to new examples. When you have tagged a bit of material, you can try to suggest some examples by pre-tagging the material and then presenting in the unseen part of the corpus only the most promising new examples. And this has a strong impact on the cost of porting this kind of system to other domains. So verbs there are playing a major role. And so this is, of course, an area in which you can make profit of the semantic labels that give you more evidence and give you better capabilities, or let's say evidence of any learning system. I was thinking to these kind of things. For example, we were applying these techniques by progressing with information extraction, and the quality of the semantic tags is quite important. If at this level we can have high accuracy, so the number of noisy patterns can be kept low. So the unvalidation phase is quite cheaper.
Can I add to that?
I think what I'm interested in, I'm looking for answers to that. Is that if you think about verbs, that they denote more or less events or relationships of some sort, and therefore they are like a higher level of objects than nouns. So in order to label a verb, you probably need to look at the arguments it takes, and that may well just decide what the labeling gives to the verb. So it's like a second order.
So that's the idea, is that if we could do this on a really big scale, then we could actually derive semantic preferences for verbs from a corpus instead of just little tiny experiments that we do now. That if we could know that these are all the verbs that have liquid subjects, and these are all the verbs that have human direct objects, we actually can derive these template structures that we, on the symbolic side, handwritten, and on the statistical side, attempted to predict on a smaller scale. We could do it on a bigger scale.
This was my idea about incremental, because you are first clustering nouns and achieving good performance in noun labeling, and then you can use to explore the right, more complex world of verbs.
You, either because you stated that one of the uses of this was in machine translation, or because you lived with machine translation people. I see this as a task for it, but I also am worried about the dependency on longness, because when you go to other languages, are you going to get dictionary? In fact, some languages are going to want to translate. There aren't going to be dictionaries at
But
all.
almost all the language modeling is translating from English. So if you have the aligned corpus, we hope to integrate with the project here, but we tackled a very big thing in the end, and so we didn't do that, but we'll try to do it in the future.
So
But if you
we
can
have
label the English side, then you can show, for examples, that you can know the correct translation. The question is whether it reduces the entropy overall, whether you can have enough of an effect to make any difference, and it needs to be measured.
I just want to remark, I mean, you probably know that we at Johns Hopkins have this project of projecting information from a well-stacked language like English to some rare languages, and David Jarowski has been leading this for a while, and it's very successful. In other words, that we are able to transfer resources which exist in English automatically to other languages. So I think that was what you meant. So So even though there are no long ones elsewhere, but there are of course languages which have quite a lot of effort, right? I mean, one of them is Czech, which actually we use all the time because the group in Prague has a tree bank and has everything. And there is this old idea of the Prague linguistic circle. So there are some languages which sort of unexpectedly have a lot of resources, and then there are others which have fewer.
Yeah. Well, the experience in mapping Longman to WordNet is just going in this direction. Because the WordNet, the American WordNet, is pointed currently by a Euro WordNet by something like 26, 23 Euro languages, different languages that are pointing to the WordNet. So you can just say, if I have a WordNet link connected with the Longman link, from this information project to other languages. And the Kalina's kind of exploration was just suggesting that this is a viable and effective.
In terms of the most useful feature, the most useful, now I'm afraid to use the term feature anymore. In terms of the most useful procedure for tagging here, you got a big, if I remember right, you got a big bang for the buck out of this IR measure. Right, out of the information retrieval measure. That seemed to be very powerful, it seemed to be pretty successful. I don't remember anything else jumping out at me as any single thing being as strong as the simple bag of words measure. I was just wondering if you could refresh my memory as to what other things were as effective, or am I remembering correctly that none of the other things were as singularly powerful?
Yeah, we had the same kind of complex picture when we tried to put all these things together. So maybe an overview. Let me just synthesize, and maybe the people here can comment. We had basically three approaches based on bag of words and the use of the dictionary only, and the use of clustering techniques basically based on adjectives, right? And they have been measured on the blind material with all the three kind of lines have 93 point something. Basically the adjectival clusters used as additional features to the kind of lexical information due to the noun seems the best cue. And they can be further improved, as David was mentioning, if you add subject code and topical information from the document. This is the general indication. When you are using parsing, you are increasing a bit the quality if you make a lot of effort for unseen phenomena. But you are not adding anything if you're looking to known words. Okay? So this seems the most effective way. The dictionary preferences, and some corpus-derived clusters, like adjectival clusters, that are suggesting you the kind of the other cases give you some preference. Is it exhausted?
I'm somewhat concerned. There's been a lot of work in this area. Okay, and essentially what the work shows, as I read it, is that yes, you can cluster words, and yes, you can figure out what cluster a word belongs to, and sometimes you can get this to reduce entropy, but when you try to actually use it for more complicated things, it breaks. Okay. And the typical thing is, I remember one example that came up at Brown, where we've also done some work in this area, was a sentence like, he saw her smile. And you look at WordNet, and you say, well, okay, so what does it say about smile? And what you discover in WordNet is that you can't see her smile, because a smile is a signal, and you can only see physical objects.
Yeah.
Okay? So, and this is not an isolated example. And so almost every time you try to do this, the world just doesn't break up into nice clusters like this. And it's not clear what we're going to do about this problem. And I don't see, I don't have a solution. I don't think you've got a solution. But it seems to me until we come up with some solution, I'm really not actually sure that this is going to, lead someplace. Mind you, I believe in clustering. I think we all believe in clustering, okay? And I desperately want for someone to succeed. But
These are clusters based on preferences, not clusters based on.
No.
I mean, I think they're a little different than the sort of Mercer Brown clusters, where they did very well on getting Monday, Tuesday, Wednesday, Thursday, Friday, but it was because they appeared in exactly the same context. But this is saying, okay, can we do something coarse with the nouns and then get all the adjectives to do it? And I don't think it is like other work that I know about as far as having the coarse category. Well,
people have done things like, take the base categories of WordNet.
Well, there are 1,000 of them. So most people, you can't get 5 people in a room to agree, is my experience. I mean, I tried to use those.
No. I mean, it's not a question of agree or disagree. I mean, there's no right answer. It's just there are lots of
It's a
things
question
you
of
can
getting a process where we could consistently even test this on a big scale.
Well, actually, it's very ambiguous, the phrase you said, right? You saw her smile. We don't know whether we're saying how she was smiling, or whether you mean that she has a peculiar grin and you saw her. But no, but I want to say more. It doesn't matter philosophically whether a smile is something you can see or not. The point is that the verb see can be associated with the noun smile.
That's right.
And that's what we are after.
But never mind. I've said my piece.
Well, it could be this isn't the right approach. It's just a little attempt to suggest maybe a way that's interesting to explore. It could be we didn't pick the right categories. And
No. I'm saying
We can debate that forever,
There
but-
is a set of right categories.
nor do I.
I mean, this is an attempt to decide the set of categories and see if we have techniques for fitting the, let's say, expectations with these categories. And maybe the categories are affected with the results, and maybe we can show this result for other systems of categories. But the idea behind this is that there is an intermediate level of under-specification in semantics that can give us information for better, let's say, for having better clusters. And this is helpful as a way to build more technologies, but it's also a way to, let's say, move the clustering-based techniques from the corpus legal kind of things where you can prove that your clusters are good just because they are very simple. And it's very difficult to eliminate and prune out the clusters that are not good because you have no special reason for doing it. So, and this is a way to compromise and trade off between pure corpus statistics and, let's say, some semantic inspired work. It's not the best way, but it's the achievements suggest maybe it's promising.
Any other question about this presentation? Is there any discussion about the 3 projects that have been, whose results have been presented? And yes.
I just want to comment, I was very impressed at the use of maximum entropy here across all 3 projects for taking what we would have called 30 years ago, trying to design an expert system and then putting all of these things on some statistical base. It seems like a very useful paradigm for this and future workshops.
Any other remarks about it?
Next year we'll use conditional time and freeze frame.
Right. Actually, Chia already suggested it. Any other things? Well, let me make some remarks. I mean, first of all, we had 3 teams here, and it's I think very interesting that all three are sort of in a different state of development. Machine translation certainly is by now quite mature. Of course, it still gets very lousy results, but it is mature. I mean, the original IBM approach is started in the late
Actually, it
80s.
gets very good results with a suitable definition of human performance.
Like that I can't translate into Hindi at all.
You're getting 105%.
Well, that's yet another point, right? And then, then we had a project on confidence in machine translation, and maybe because of the lousy results in machine translation, that's a premature project, but they certainly had to start with something. And then we have the project on semantic tagging, which is something that we all hope for, and in some sense, of course, sense disambiguation has been around for a while, but in some sense, it opens up new vistas. Also, I'd like to say that the three leaders, namely Franz, George, and Louis, may appear to you as people who kind of present are figureheads, but actually they worked incredibly hard and contributed definitely to the results. I mean, Franz didn't claim any of this sort, and neither did George, and neither did Louis. But they've been here many nights till 2 o'clock, or Franz till 5, and
George till 6.
George till 6. So this is how it goes. I mean, when I described how these things work to Louise, I was saying, she thought that originally that she's going to be here from, well, not from 9, because she doesn't come in at 9, but, but maybe from 11 to 7. And I said, no, you're very wrong. You're going to stay here, and by the end of the last 2 weeks, you're going to stay here all the time. And that's what happens, and it happens absolutely to everyone, to all the mature scientists and to the undergraduates and to the graduate students. They just stay here, and eventually a certain panic sets in, and they don't want to leave their computers. Next thing is that at least we believe that we have really found a great way of educating undergraduates. And of course, we start with fantastic material, and you should realize that we have chosen 8 undergraduates out of 120 applications, and they are worldwide. And you've seen we have a Bulgarian student, and we have students from everywhere, and we don't discriminate. And so this is getting to be a worldwide competition, and they are just absolutely first class. Our graduate students are, of course, very good too. But the point is that the undergraduates, that from the work accomplished, you can't tell the undergraduates from the graduates. And maybe this has to do with the advances in computing. The fact is that the undergraduates come as mature programmers at least, and we give them these 2 weeks of initial instruction, and they are somehow able to catch on. And if NSF really had more projects like this, maybe we could educate the whole country. Okay, I think that's about all, except that, of course, we're always looking for topics, and we, of course, expect to have another workshop next year. And we are somewhat always in trouble with deciding what topics to choose, and if somebody would really shake the trees. This is a marvelous opportunity. I mean, you have seen here how many people come from how many different backgrounds, different universities. You can't get this kind of cooperation at any particular place, and of course this cooperation will continue, and you will see in the next year or two how many papers are going to be published, and they will be published cooperatively with people who come from widely distant sites. So, all right, so I don't know if anybody wants to make any other concluding remarks. We have been extremely happy to have you, and we are going to celebrate tonight at the banquet, and you know, wine will flow, and maybe even some cocktails, and the food will be good, so we're looking forward to seeing you then. So thank you very much for your hard work.